Hello. Today we will discuss about the frequency analysis of a spring mass system, and we will consider the mass of the spring. So derivation for how to find out how to find out the natural frequency of spring mass system. Okay, suppose let we have this is a spring mass system. This is a spring mass system. This is mass m. This is spring constant k. Given data, we have given spring stiffness is equal to k, mass body attached to spring is equal to m, linear density, linear mass density, linear mass density of spring is equal to rho total mass of spring is equal to ms, and length of spring is equal to L. Let we have displaced this mass through a distance x. Now the new diagram, this will be this is the displacement x, mass is displaced through a distance x. Now we will find its natural frequency by using the conservation of energy, method. So when we displace this mass, we had two type of energies. First one is kinetic energy and second one is your potential energy. First of all, we will find the potential energy of the system. Potential energy in the potential energy in the system or potential energy stored in the spring, potential energy stored in spring is equal to potential energy is equal to k into x, sorry, half x square, half k x square. This is the equation 1. Now kinetic energy of mass m is equal to half m x dot whole square, where x dot is the velocity of mass m. Now this is the equation 2nd. Now we have to find out the kinetic energy of the spring. Kinetic energy of spring. Let we take a small element. This is small element of the spring having length dy at a distance of y from the point O. Well, total length of the spring is equal to L. Now first of all we will find the kinetic energy of this small element. Kinetic energy of this small element. So kinetic energy of element dy is equal to half dm into velocity of y element, dy element whole square. Here this is the equation number 3rd. Now dm, but dm is equal to rho into dy. It is equal to ms divided by L into dy. And v, velocity of dy element, is equal to x divided by L into y. Now put the values of dm and vdy in equation third. So kinetic energy of element dy is equal to half into ms divided by L into dy into x dot into y divided by L whole square. It is equal to half ms by L square into x dot y into dy. Now we can obtain kinetic energy of whole spring is the integration of this small element from 0 to L. We will take the integration from 0 to L length to find out the kinetic energy of whole spring. It is equal to half ms divided by L into dy x dot now kinetic energy of whole spring is equal to integration of 0 to L half ms divided by L square into x dot into y into dy. Now we will take the constant term outside of this integral, half ms divided by L square into x dot integration 0 to L y into dy. Now it is equal to half ms divided by L square into x dot kinetic energy of the element is equal to half ms by L into x dot square divided by L square into y square into dy is equal to half ms by L cube into x dot whole square into y square into dy. Now kinetic energy of whole spring is equal to integration of 0 to L 1 by 2 ms divided by L cube x dot square into y square into dy, which is equal to 1 by 2 ms divided by L cube x dot square into y cube by 3 1 by 2 ms by L cube into x dot square into L cube by 3. L3 cancel out L3, so it is equal to 1 by 2 ms by 3 into x dot square. This is the equation number 4. This is the equation number 4. Now so total energy of the system, total energy of spring mass system, spring mass system is equal to kinetic energy plus potential energy, and this is equal to, this energy is equal to constant. Now kinetic energy is equal to kinetic energy of mass, kinetic energy of the mass m, that is equal to half m x double dot square plus kinetic energy of the spring is equal to half ms by 3 into x dot square. So this is the total kinetic energy, then plus potential energy of the system is half k x square. This is equal to constant. Now this is the total energy E, then dE by dt is equal to half then energy is equal to m constant. M x double dot square ms by 3 x dot square plus kx square is equal to constant. Then m plus ms by 3, we will take common, x dot square, we will take x dot square as a common, then m plus ms by 3 plus kx square is equal to constant. Now take differentiation on both sides. It will become m plus ms by 3 into 2x dot into x double dot plus 2 kx x dot is equal to 0. And m plus ms by 3 into x double dot plus kx is equal to 0. This is the governing differential equation for this spring mass system. So we have to find out the solution of this differential equation to find out the natural frequency of this spring mass system. So the governing differential equation is m plus ms by 3 into x double dot plus kx is equal to 0. This one is the inertia factor and this one is the spring factor of the system. Now natural frequency of the system, that is equal to under root spring factor divided by inertia factor. So W1 is equal to under root kx divided by k divided by m plus ms by 3, which is equal to under root 3k divided by 3m plus ms. This is our required result.